How to clean your indoor air and surfaces tutorial. Gas stoves, electric stoves, kitchen ventilation, electric and magnetic fields, and nitrogen dioxide. This is chapter 13. Be sure to check out my other videos. Gas stove pollutants. So when you're cooking food with a gas stove, you're going to get a lot of air pollution, some of which are ultrafine particles. All that means is the particles are very small. You're going to get nitrogen oxides, specifically nitrogen dioxide. This is very toxic and very easily amenable to ionization. Air ionizers turn nitrogen dioxide into nitrogen and oxygen, so it's perfectly normal air. You're also going to get carbon monoxide, and you can look at the health standards chart to know what's healthy and not healthy. You're going to get volatile organic compounds. So it's important, again, we use our air monitors to monitor the air in the kitchen while we are cooking. Nitrogen oxides. So a lot of times nitrogen dioxide and nitrogen oxides are used interchangeably. They shouldn't be, but sometimes it's just easier. So nitrogen oxides come in many flavors in the atmosphere and in the home. Sometimes we usually just say nitrogen dioxide because that's what's most common. Nitrogen oxide toxicity. As you can see, every part of our body is affected by this, from the skin to the heart to the brain. And it's just important to know air pollution is merely always toxic. Nitrogen oxides pollutants in the ambient air are a potential source of neurodegenerative disorders, including Alzheimer's and Parkinson's diseases. It's especially toxic for children, and again, it affects every part of our body. We do not want to inhale nitrogen oxides. NO2 standards. So the more NO2 we inhale, the more toxic it becomes. If it's high enough, we could even die. The bottom right hand corner, we have our standards chart for nitrogen dioxide at 53 parts per billion. That's considered excellent air. Personally, I think that's way too high. 20 parts per billion was shown in this study to still be toxic. So this is why it's really important to have an ionizer in your kitchen, because it completely cleans NO2 from the air. NO2 in homes. So in the top left hand chart, you can see different NO2 amounts in different homes. It can be very different based on your home setup. And in the next chart, you can see measured NO2 emissions from gas stoves. This is very accurate. So when you're cooking, your air monitor, your NO2 air monitor will skyrocket, and this is NO2 in the air, and this is why you need air ionizers so that number does not go up. In the right hand image, you can see during warmer season you have less NO2 in the air because your windows are probably going to be open. But in the winter, since your windows are probably closed, you're going to have much more NO2 in the home. So again, this is why we need ionizers, because instead of having 197 parts per billion NO2, you'll have 0. Electric stove pollutants, also known as EMF. So this is air pollution. So with an electric stove, we have to manage the radiation. So in this study, they measured EMF with different types of cooktops, and you can see it actually ranges a lot. So it's not the same EMF per what type of cooktop or electric stove you use. Some models, some brands are better than others. So again, here you can see measured cooktops, and they range a lot. And over time, what's been considered toxic has changed. So these standards are never consistent. Everyone has their own standard, what they consider to be toxic and what's not toxic. So in the bottom left hand corner, you can see the FCC limit for specific absorption rate exposure. Again, there's a lot of terms and phrases to describe radiation, and this type of radiation is not the same as radon radiation. So there's a lot of standards one needs to know for this topic. In the right hand image, you can see when you're near a microwave, a lot of EMF. The further you go away, much less EMF. So here are many charts for EMF radiation standards. Everyone has their own standards. I'm actually trying to formalize what's good, what's not good, and I'm reading all the data, so just give me a little bit of time. But I did want to notate that EMF toxicity changes per what frequency or the device type. It's not just like a one chart thing, it's going to be many charts. EMF Visually. So here in this image, you can see an EMF emitting source from the bottom center of the room. By the color chart, you can tell the further you're away, the less toxic it is. So let's say with a microwave, you want to be at least 3 feet away from the microwave to have the least amount of EMF. And you can apply the same concept to electric stoves. Average home EMF. So The electromagnetic field in every home is going to be different based on where you live and power lines near you and many variables. In 1996, 746 homes were measured in San Francisco. As you can see, the natural EMF in the home can be radically different from the next. Is EMF toxic? Absolutely. So on the chart on the left, you can see a bunch of studies done with EMF and the health effects. And you can see in these other images that this causes oxidative stress directly and indirectly. EMF radiation is toxic, and I'm not saying we should not use electronics anymore, that's silly, but we just need to be self-aware. We don't want to hang out near the microwave or router all the time. It's probably not the best thing for us. EMF Clothing and Shields. They never work, ever. So if you see something that says, oh, protect yourself from EMF, it does not work. You cannot block a magnetic field. Unless you wrote new laws of physics, it's simply not possible. More stove oven pollutants. Volatile organic compounds are always created. Ozone as a byproduct may be created. Ozone could even increase drastically. Constant chemical reactions are taking place regardless to produce new pollutants. So it's something to be aware of, that when you're cooking, there's constant chemical reactions and a bunch of different things can show up on your air quality monitors. This is why we use ionizers in the kitchen. So the more unclean your appliances are, the more polluted toxic chemicals it will emit into the air while you're cooking. You may want to consider wearing an N95 mask while deep cleaning your stove and oven. So it's important to keep your appliances clean, because the more grime there is, that stuff gets in the air and into our lungs. That's not good. Kitchen exhaust fans. All cooking surfaces, electric or gas, require a hooded exhaust fan rated for at least 100 cubic feet per minute. Vented hoods rated for more than 400 CFM must have some means of providing makeup air. A fresh air intake that prevents the exhaust fan from creating a partial vacuum in the home that could potentially cause backdrafting of exhaust gases from other fuel burning appliances. Vent fans should be ducted to the outdoors through a sidewall or through the roof. Ductless recirculating exhaust fans, although allowed in some jurisdictions, they are poor substitutes. Ducts on range hoods must include a mechanical damper that closes over the duct when air is not blowing through it. Inside wall venting, this can be a damper on the vent cap itself. In roof vents, the damper is usually fitted into the ductwork. Kitchen exhaust examples. In the first image, you can see the type of hood that's vented outside. In the second image, you see the type of hood that's vented indoors and might have a carbon filter inside of it. The last two images, again, it just shows how air can be circulated inside or outside and how it would look like with the vent going outside. Kitchen exhausts with fresh air. So in this example, the exhaust fan is very strong, so you need fresh air to come out so you don't get the backdraft. So again, this is just an example. So here are more kitchen exhaust setups, and you should just be very familiar with what type of setup you have. I'm not saying you shouldn't upgrade or anything, but you should know what setup you have. So you should look at your make, model number, look it up online so you understand what's going on. Again, I just want to show you more images of kitchen exhaust setups. So this is something just to, introduce you to this topic. I highly suggest reading more into it if you are interested. Alright, so let's talk about actual cooking. So if you have a kitchen hood that's unvented, when you're cooking, all of your air quality monitors are going to skyrocket. It's going to show bad air, especially for NO2 and particulate matter, especially when you're frying foods. If you're using the oven, ozone could increase. So in an unvented scenario, opening windows is usually a very good idea, along with using air purifiers, ionizers in the kitchen. The better your kitchen exhaust fan is, far less pollution will accumulate indoors. No matter how powerful or great your exhaustion setup is, you will always have some pollution indoors. It's not perfect. You can have the best, most expensive exhaust fan in the world. You're still going to have air pollution indoors. Thus, it is recommended to always have an ionizer turned on 24/7 in your kitchen. You will still have all sorts of polluted air just the same as a gas stove with an electric stove. You're merely trading NO2 toxicity for EMF toxicity. So gas stoves will give you a lot of NO2, electric stoves won't, but they will give you EMF radiation. I'm not saying one is better than the other, it's just simply a good idea to be self-aware what kind of stove you are using. Air monitor ionizer placement. Generally speaking, you want to keep each device about 3 feet 1 meter from each other. If your air quality monitor is too close to your kitchen appliance or to your ionizer, the numbers may not be accurate. Panasonic ionizers also say directly in their manual, do not place within 1 meter of the kitchen stove because there's too many particles, air pollutants going on in that concentrated area. So something to be aware of. This image is just an example. Obviously every home is different, but you want to keep these devices just a little bit away from each other. Be sure to check out my other videos. Let me know if you have any questions.